really interesting topic, interesting way to present the ideas. Murat has unfortunately been stuck on public transport this morning. There's been some disruption somewhere, so he's not going to be back home for probably another 20 minutes, so too late. So I'm going to give a talk instead. Sorry, it's probably a slightly less interesting format. I'm just going to talk to you and show you some visuals, but hopefully it'll still be interesting. I'm going to talk about continuous architecture. That's the approach that I didn't come up with, but Murat, Erder, and Pierre Burr, the authors of the original continuous architecture book, did, and I joined forces with them to write another book on continuous architecture called Continuous Architecture in Practice, which is in this series, which is why we're here today. Thank you very much for having us. I'm CTO of a company called Endava. We build software for other people. There's about 12,000 of us around the world. I've actually been there for 8 years, not 6. That needs an update. And before that, I spent about 20 years developing software. I do have a previous book on software architecture, which is somewhat different in nature. And I've done various things in the community in Germany and other places, in fact, especially in the UK. The reason continuous architecture came about is because architecture work is changing. And this talk, in the interest of full disclosure, I will finish at 10:45, is really a rather longer talk introducing all of continuous architecture. But I think what's interesting today, you can read the book, of course, and there are videos on the internet about it. I'm going to talk a bit about why it came about and why continuous architecture is important today. So it's because we need continuous architecture in what I term a digital age. The reason being, where the kind of systems that a lot of us are building today are rather different to systems we've built before, and that has resulted in different kinds of software engineering approaches. I describe the characteristics of these systems as they're intelligent connected platforms. The 3 words meaning platforms are the most important. A lot of us are building platforms today. They're systems where we don't entirely know what they're going to be used for. And it's not just a case of us having to change them later. We expect other people to build on top of them. My canonical example of this is, of course, Google Maps. I'm pretty certain when they sat down and started sketching the initial code for a mapping application, they weren't thinking about public transportation, restaurants, shopping, tour guides, running guides, and all the other things people have built on top of Google Maps. So they had to build a platform with APIs that allowed people to extend it. Cushion, which you may well not have heard of, they're quite well known in the USA, but they don't operate in Europe. They're really interesting. What they do is they suck in your bank transactions from all of your banks, wherever they are in the USA. And the simple thing they do, actually not simple, but the core thing they do, their core business, is they interrogate all those transactions using machine learning algorithms. They spot where you've been overcharged for your banking and your credit card fees, and they automatically claim those back. And in the States, apparently that's a big problem. UK, I don't think that is a very big problem, but in the States, it's a big problem. A lot of people use Cushion. Clearly now, what Cushion can do, having created this ability to suck in all the transactions and do analytics on them, they can create lots of other applications and invite other people onto the Cushion platform. And then Salesforce, another classic platform, they started building a CRM system. They ended up changing the world with a SaaS-based ecosystem where the range of applications built on top of the underlying core, Lightning, is quite remarkable. I'm quite sure when they sat down and said, let's do a CRM system, and Benioff said, hey, let's access it over the web, and everyone told him he was mad. They weren't actually thinking, wouldn't it be great if people built all kinds of things on top of our underpinnings? There are many other examples of these, quite possibly in some of the companies that you're working in today. So why does this matter? The problem with digital platforms is, especially public-facing ones or B2B ones, is they're always on. They typically today have to exhibit intelligent behavior because people get intelligent behavior from Google Maps and Google searches and Salesforce. They sort of expect it everywhere. They're highly connected. Typically today, they don't have a single database. They don't manage all their own data. Data's coming in at them from many different angles and perspectives. They're quite often publicly accessible, whether that's a limited public, such as your partners, your business customers, or whether that's the world. They're nearly always cloud-based. They nearly always have to deploy pretty regularly because they're often working in a very dynamic, competitive environment, and they tend to evolve in parallel. And this is key to why we recognize that architecture had to change, is that there tend to be a lot of different things going on at once, partly because of the platform nature. The platform actually may not evolve that fast, but all the different pieces on top are all evolving as separate streams of work. They're separate products in digital product terminology. tend to have to support many user interfaces. They have often got quite an unpredictable direction. After all, if you build a great platform with APIs, you have no idea what people will do on top of it, and then they will create a shower of requests for the platform to change to support their particular needs. And so they have to be extensible by design. So, we can agree that's quite hard. That's quite a big multi-dimensional challenge for software engineering. How has software engineering practice, never mind architecture, has software engineering practice evolved generally in the last 10, 15 years? Of course, Agile came along. Instead of trying to figure out everything up front, we said, let's get started, let's be adaptive to change, let's have the engineering practices that minimize flatten the cost curve for change, keep change roughly unit cost right through the life cycle. And what happened with Agile? Lots and lots of teams produced demoable software at the end of sprints and couldn't get it anywhere near production. And the response to that, directly or indirectly, was cloud. And then cloud infrastructure, of course, brings the dynamism of Agile delivery to infrastructure. We no longer raise a ticket, wait 6 months for a server. We write a short piece of CloudFormation code, and before we know it, we have a server, and et cetera, et cetera. Then, of course, what happened was the infrastructure people called our bluff and said, go on then, you can release every 2 weeks. And we went, oh, actually, it's quite risky to release every 2 weeks. We'll do it every 3 months. Of course, again, not really getting the benefits of Agile. So one of the drivers for microservices, and to even more extent serverless, was we can release in parallel, therefore we can release smaller bits, therefore we could release much more quickly. We also started using reusable cloud services, fantastically powerful things. We use quite a lot of, for example, Azure Cognitive Services, quite amazing things we probably couldn't build ourselves. It would take us a very long time to build, even with our AI machine learning team. However, very unpredictable quality properties. Typically, we also hear this about cloud databases. In the aggregate, they're fantastic. Sometimes they have quite unpredictable quality attributes. And even if they're not unpredictable, you have to live with them the way they are. You can't affect that very much. And then finally, of course, the people who were left out of the party up to this point, the people who had to look after it, operations. And so DevOps and SRE practices emerged so that we have a full end-to-end cross-functional team, not just a cross-functional team delivering software. All this has meant that architecture has become much more fluid and evolves much faster than it did when Nick Rosansky and I wrote that original book that I referenced at the start, which was, gosh, 20 years ago. It was quite a long time ago. When I started my career as an architect, things just didn't change in this way, partly because of expectations and partly because of constraints. So what does that mean for us? Well, it means that if we have Adriana, the architect, working with a number of teams, there's 3, but imagine there's 20, the problem will be that everything will start well and people release to production. But as we know, software developers are rarely short of opinions or questions. Because it's all happening in parallel and we haven't got these big predictable pieces of delivery where we can sort of do some architecture work and it's stable, one person is going to get overloaded. And then one of 2 things happens. Either the teams just get on with it and you don't really have an architecture anymore. You've got 20 teams, you've got 15 architectures, or everything slows down to a bit of a halt and the architect becomes very, very unpopular. And even if you've got a team of them, they're very, very unpopular because they're seen as the people blocking everything. The people who like to say no, which of course is the last thing most architects want to do. And the reason for this, of course, is if you've got autonomous teams, you get independent activity, you get a lot of decision making in parallel, and then the architect gets overloaded and you'll either get, let's not call it chaos, but you'll get a lack of alignment, I think is the polite way of putting it, or you'll get block progress. And of course, the other thing we want to bear in mind is if things are changing constantly and we're very dynamic and we can't predict where our platform's going, it's rather difficult to predict what we'll be doing with it in 2 years' time. We know a lot less early in the delivery process than we did in some years ago in more traditional systems building. And in some domains, actually, you do know a lot about what the system's going to be doing in 5 years' time. But in digital platform domains, I've repeatedly observed it's very, very difficult to predict. Therefore, we know less early. Therefore, if we're going to see architecture as an upfront activity, which I will put my hands up and say, until about 10 years ago, maybe a little longer, I viewed architecture as a largely upfront activity. And you can see that in our first book. There's still an awful lot of good architecture practice in there. An awful lot of it is valuable to apply to today's systems, but we pretty well assumed that architecture was mainly at the start and mainly at the end and not so much in the middle. And that's what's changed because you just know less, you can predict less, there's less value in doing it early. continuous architecture is a coherent approach to addressing this challenge. And there are other approaches too, but it's a specific, coherent, well thought out approach to meet this challenge. So what is it? Well, the first question is, do you need architecture in this kind of situation? Unsurprisingly, as a career software architect, I would argue yes, but I do have a reason. It's not just because I think it's a nice idea. Systems still need to achieve their quality attributes: security, scalability, performance, regulatory compliance, all of those things. Usability, blah, blah. I could go on. You know, it's a very long list. Those are difficult for individual teams working on parts of an overall platform ecosystem to achieve by themselves. One team cannot make itself secure. It relies on everybody being secure together. Scalability tends to be something where you've got to view it in the whole rather than one team hoping that its bit is scalable. We also need to balance stakeholder concerns. There are many people interested in our system, some very positive, who desperately want it, some quite negative, typically audit and compliance, who wouldn't be too worried if it went away tomorrow, because to them it's a source of risk. There's people involved in disaster recovery, there's the people paying for it, there's the people operating it, and so on. Something I've observed repeatedly is that individual teams find a blizzard of stakeholders very difficult to deal with. It really affects their productivity and their focus, and they find it difficult to deal with all those people and make trade-offs. Someone's got to do that, and that tends to be architects and business analysts, of course. The two are closely related in that particular area. And in all systems, there are complicated trade-offs to make. If it was easy, it wouldn't be fun, and all systems would just arrive on time and be perfect. And of course, there are complex trade-offs to make all the time, and they tend to be systemic trade-offs. Again, if one team decides they're going to trade usability for performance, and another team wants to stress performance, usability over performance, over usability over performance, excuse me. In other words, they're pulling in the opposite directions. That's going to create a very, very difficult environment. So the activity of architecture, I would believe, is still inherent because we have a lot of what I term cross-cutting concerns, things that go right across all the delivery teams with their independent empowerment. So architecture is still important, but I will posit in this environment, we're going to have to change the way we do architecture to be a flow of decisions rather than an upfront, perhaps high ceremony design exercise. So what do we do in this world? Well, the key things about it are architecture, I believe, is now a skill, not a role. I'm not against architects at all. In Dava, we have hundreds of architects and they're fantastic and they make a huge contribution to our projects. But actually, their role today, and we see this all the time, is it's as much facilitating, encouraging and coaching architecture work as it is doing all the architecture work. We need a lot of people with architecture skills. Rather than creating an architecture and then building it, now architecture has to reorient itself to be a stream of decisions. Of course, you need to make some decisions at the beginning, otherwise you can't make any progress. But one of the principles of continuous architecture we'll look at in a minute is deferring your decisions as far as you can. Of course, judging that last moment can be difficult, but it's deferring them as far as seems responsible. When we've got a very dynamic system made up, and it's quite fine-grained, we've got a lot of moving parts, I have observed that keeping models up to date and defining the fine-grained structure is of less value than it was. When I started out, a complicated system probably had 12 major components, pieces, services, databases, request handlers, whatever it was. About 12 was quite a complicated system, and you could get yourself into a right mess. And those are 12 quite monolithic things. You can still get yourself into a right old mess by connecting those up badly. However, today we've got hundreds of pieces in many systems. Trying to keep a model, a manual model, and direct that is very difficult. So instead, what we need to do is be clear what our architectural design principles are, define the architectural styles we want people to follow, and agree the patterns that people would use when they're implementing their components. And then we will get alignment and cohesion and an architecture that meets its goals without having to tell people, well, don't split that microservice in two because it isn't, that's not my model. Part of this is about delegating and sharing, trying to move architecture artifacts to being a shared commons. And the reason being for this is that there's so much parallel activity going on, you can't control it all, even if you wanted to. So it's important that we delegate and share so that people feel collective ownership, and in particular a sense of responsibility towards architectural qualities. And we do it little and often because that allows adaptation. if we try and do a lot at the beginning, it's quite hard to adapt because we've got our ideas, we've done our thinking, we're ready to go, and then something changes. I'm arguing that in the platform world, change is faster, more dynamic, and more severe. So actually doing our architecture work regularly right through the life cycle is quite important. As I say, Empress shared commons. View architecture as everybody's responsibility and creation rather than the architect or the architecture teams. Clearly, your junior automation testers are going to have less input into the architecture than your, principal test engineer, of course. But we want to get people thinking about it as a collective responsibility, a bit like we've done in the last 10 years with security, which has been a big change as well. So the continuous architecture approach, actually, what does it comprise? The key thing is a set of 6 principles. Principle 1 is architect products. Don't run your development as a series of projects. That today is not very radical. When the book was written in 2015, this wasn't a very common practice. Now it is a very common practice. Principle 2 is focus on quality attributes, just what we were talking about. Other people won't, or even if they do, they don't have the right perspective to be successful with that. So focus on the quality attributes. Teams, product owners, business analysts, they'll do a great job with the functions. They probably won't do a great job with the quality attributes because of their position and perspective. You were saying stuff's going to change. So delay design decisions until you can. That doesn't mean don't make them. It doesn't mean defer them until you have to make a panic decision because people need it tomorrow. But it does mean looking out into the future. This is quite a common thing. Backlogs of decisions that you think will need to be made, and then regularly reviewing when you think you have enough information to make them, and when it's going to become critical for that decision to be made. Principle 4 is about embracing change and recognizing that, as the microservices community did, and incidentally, we're not saying everything's a microservice. We're not saying you use microservices. What we are saying is bear in mind that you'll have to change the system quickly and probably in parallel. So the catchphrase is leverage the power of small, although we're all Europeans, Pierre lives in America, so we got leverage. So leverage the power of small. In other words, it's easier to change smaller pieces regularly than change the big thing regularly. Principle 5 is remember that it's only valuable when it's in operation, and the way that manifests itself is we've got to make sure we don't just design how the software is going to work. We have to make sure that we can build it effectively and quickly, we can test it really, really effectively and quickly, we can deploy it quickly, reliably, repeatedly, and we can operate it with minimal effort and maximum reliability. And all of those are architectural concerns, which again, historically, architects have tended to go, I've created a beautiful structure, we simply need to implement that, and my work here is complete. Of course, there can be quite a gap from beautifully implemented software structures to valuable software in operation. And in fact, principle 6 is modeling the organization of your teams after the design of your system. Previous speaker was just talking about teams and topologies. That's really what we do these days. We point at Matt Skelton and Manuel's work and say, team topologies has got a lot to say about this. What this principle is really saying is bear in mind, the structure of your teams will have a direct effect on how they work together, the kind of flow you get, and the structure of your software. So make sure that that all lines up. But we really point at team topologies. Just skip over that. The way that it manifests itself is that the key thing is that rather than trying to produce blueprints up front, which we think have less value than they did, not to say you never create a model, not to say you don't produce a blueprint, but lots of blueprinting up front we think is less valuable. Then what we're saying is it's quite subtle when you look at it. It doesn't jump out at you, but the important point is typically there'd be architecture sort of quite upfront, almost in its own circle. We're saying architecture is just, it's very important, but it's just an activity that's done in every increment of the excuse me, of the system delivery. The key things that come out are architectural knowledge, which can absolutely include models, but includes lots of other things too, such as mathematical models and trade-offs and domain knowledge and knowledge of business priorities and so on, and then architectural decisions. Again, 5-6 years ago, people weren't really talking about decisions. It's fantastic now that people are, and as we've been saying for some time, decisions are one of the primary outputs of architects, and they need to be made thoughtfully and based on facts, and architectural decisions need to be curated. They need to be somewhere that they can be found. So what we're trying to do is move from quite a lot of quite prescriptive, quite top-down, quite detailed architectural design to defining a set of styles and patterns. Here's how the system is going to work. Here's the architectural style. We're going to have a blackboard in the middle. We're going to use event-driven architecture behind the blackboard, and the front and at the front we're going to use micro front ends delivered via a very traditional client server based system with UI request handler. Those are three architectural styles which we're stating our system is going to follow. What we're not saying is the blackboard's going to have 14 listeners. Here are all of their functions in detail, which is what we would have done before. The other thing is that when people are building bits of the software, we would like it to work in a very similar way. So my bugbear here is logging. If you cannot agree on logging patterns and standards, you just get a mess, and it's very, very hard to work out what's going on. But there are many more too. Request processing, how we handle databases, what's our approach for reliable message processing. All of those things, we need to agree on approach. We need to write it down as a pattern so that everybody understands it, can use it, and ideally, we can implement it as a reusable little library, and that we have a library of patterns which are written down so people understand them, and then code which implements those patterns people can reuse. I know it doesn't always work to build them as libraries. Sometimes they're more trouble than they're worth, and they actually introduce problems, and actually we should let people implement the patterns. But of course, if you give people the libraries and they're good, people tend to just use them. If you ask people to follow the patterns, they may or may not. There's then a set of principles. This is not the principles of the approach, this is principles for your system. Guidance so that you get aligned design decisions. What is important, what is not important, really. And then a set of decisions. So we understand what we decided, when we decided it, and why we decided it, so that we can come back later and say, why on earth are we using a document database? It's causing us all kinds of problems. Well, that decision was made 3 years ago. However, we've got a well-reasoned decision. We go, we've seen how. We didn't do much traversal, did we, back then? And we thought we could handle the traversal via keys embedded in the documents. Yeah, that kind of made sense then, didn't it? It makes no sense now. And so, you've got a rational reason for changing a decision, rather than it just being, we don't like it, someone else did it. Which is sometimes how it looks. And so what we're trying to create is an evolving shared design. I will skip this. And the essential activities of a continuous architect, or it's not really just the architect, the essential activities we want the architect to be encouraging, leading, mentoring, coaching people on are the senior people providing leadership. So there's plenty of technical leadership across the team. People know what's important. They're challenged to deliver technical excellence. They're challenged to do the best work that they can. A focus on quality attributes, because again, apart from your architectural thinkers, people tend not to think about them very much until it's far too late. Drive architectural decisions. Notice I use the word drive, not make all. So we want to drive architectural decisions, make sure good architectural decisions are made, congruent with those principles, align with the styles and patterns, make sure that they meet the needs of the system, achieve those quality attributes. Actively manage technical debt. Again, we deal in Endeavour, we get a huge number of inbound requests from typically new clients, but also existing clients saying, could you come and take a look at the system for us? We don't really understand it anymore. It's very, very hard to change. We've got 40 developers wrapped around it, and they're making no progress. And every time, you've seen it 100 times yourselves. Every time we go in, it's basically a technical debt problem. Not every time. Okay, occasionally it's organizational, occasionally it's the technology, occasionally it's the way the business are behaving. It's very, very often, and sometimes those things contribute. It's very, very often a technical debt problem. And this is why I believe if you're going to have sustainable fast change, managing technical debt is absolutely crucial. And that's why continuous architects need to make sure that is being done. In fact, they probably need to do it themselves. And finally, the whole point of being able to change quickly is to be able to react to more knowledge. How do we get more knowledge? We build in feedback loops. In fact, there's an entire book written not so long ago I contributed to called Architecture Metrics on that very topic. But the key thing is there are some feedback loops which are internal to development, things like static code analyzers, things like tests, things like deployment times, and then there are some which are external, which is what we measure from the business or from the operational environment to find out how well our system is doing. For example, value of transactions that it's processed per day over the last 6 months, that kind of thing, rolling averages. Implement feedback loops, because without feedback loops, we don't know if we're getting better or worse, and it's very, very hard to know where we're going. Okay, I'm just about out of time. So to conclude, Software development is changing, and this means software architecture needs to as well, and already is changing. Agile and DevOps are changing how we work. Um, Things like cloud and containers, those are only examples, are changing how we build. Upfront architecture is less valuable than it was. Quality attributes, trade-offs, and stakeholders will be with us forever. They're the core of what we do. But we need to rework our work to being a flow of decisions and guidance rather than our historical approach of trying to work out all of the structures up front to achieve the quality attributes. We just need to be smarter about how we do it. And this changes how architects work. That's why Pierre and Murat wrote continuous architecture originally. That's why we wrote continuous architecture in practice, to try and give, the original book is very much about what is it. Here's a bit like I've done today, but maybe a bit less background on the why. What is it? Continuous architecture in practice is very much the how do you actually go about it. And I'm very pleased to say that a number of my colleagues at Endava, without any pressure from me whatsoever, actually picked it up, and they use it on client engagements to help clients evolve their architecture practice, because a lot of them are, I wouldn't say stuck, but they're in that traditional upfront architecture mode, and they're not quite sure how to make the leap. And this is one of the approaches that can help. And of course, we need to, when we train architects, be training them in a continuous approach really from the beginning. They need to understand the upfront approach and its strengths and weaknesses, but they really do need to be good at doing the continuous approach. Because we want to move the architect, if you have architects, from being a purveyor of wisdom, who sort of hands things to teams and teams respect them very much because they're very, very clever and just do it, to being that trusted leader and advisor in the middle of everything, with the teams collaborating around them, but the team is being empowered to do a lot of the detailed work. Finding out more, there's the original Continuous Architecture book, that's Pierre Murat. There's Continuous Architecture in Practice, that's the book the three of us wrote together. As we said, for Principle 6, we recommend team topologies. I know that's not a particularly original recommendation, but we do think it's very good. I happen to know Matt quite well, and I've met Manuel a few times. I just think what they've done there is great. And so we don't try and build on that. Software Systems Architecture is my other book. I just mentioned it in passing. It's much more of an upfront book, but all of the advice on how to achieve quality attributes and how to organize the architect's work and the practices of architecture, well, that's all still perfectly valid. It's just that we now would interpret all that in a continuous way. And two other books, just which I don't talk about continuous architecture specifically, but are very aligned with the approach, are George Fairbanks' Just Enough Software Architecture and Mike Keeling's Design It. Finally, there is another approach to continuous architecture. It's very, very congruent. It's very aligned with what we talk about, but it's created by a French consultancy and by the Michelin organization. Michelin uses obviously throughout Michelin, but there is a website you can go and see what they say about continuous architecture. So it's continuous-architecture.com. If you don't use the dash, or you use it.info, you'll come to our website where we talk about what's in the book, and we've Pierre in particular has written quite a few blog posts expanding points from the book, particularly based on questions. So thank you very much indeed. I just finished 1 minute over time. Sorry about that, but I hope that was interesting, and I'm sorry you couldn't have the conversation. Maybe we'll do that another time.
Thank you very much, Ian. Thanks for being so flexible. That was a lot of excellent content in a very short amount of time. And we have a question, and that was asked by CC. The question is, what communication strategies do you use to convince stakeholders and business of the importance of continuous architecture?
That's a great
Go into that, please.
So, let's switch stakeholders, I suppose. I think you're probably talking about influencers, people like, development managers and VPs of software engineering and those kind of people. The main thing is I point out that I ask them really questions about how do you balance between your different stakeholders. For example, I'll bring up sort of non-obvious ones like, do you have a disaster recovery group? They go, oh yeah, they're really awkward. Well, okay, so but it's very valid. How do you balance their needs with the product owner? And they tend to go, well, it's kind of difficult. And then you then talk about quality attributes. And to be clear, I'm not trying to make them feel threatened or make them feel small or make them feel that they're not competent. I just try and help them reflect on the problems I'm pretty sure they've got, because nearly everyone's got them. And then I show them how continuous architecture can avoid some of the traditional problems, because in their minds, a lot of people, you say architecture, they go, TOGAF. I go, I feel your pain. this is not TOGAF. In fact, it's the opposite of TOGAF. And then I sort of lead them through how they could address those problems using continuous architecture.